Alrighty, welcome to lesson 7.2 part 1, where we are going to be finding inverse functions. The difference being, we've talked about inverse functions a little bit in class, but we haven't actually manipulated an original function to find its corresponding inverse function. So that's what we're going to do in this video. Okay, so this is just a quick review about what we talked in class. So for the most part, you probably already picked this up in class, but just to recap, just to review, because it is important. In mathematics, sort of a quick definition, an inverse function basically undoes another function, right? It will undo another function. So like if you have x squared, how do you undo an exponent of 2? You take the square root of it, right? And so that is what we mean by inverse. Now, we're going to get a better definition of inverse later in the semester because there are all sorts of theorems and stuff we can do in a discussion about the term one-to-one, but I'm not really going to be talking about that in this video. This is just the basic idea of swapping x and y's for inverse functions and then finding the function itself. Verifying inverses and restricting domain and things like that, that's going to come on later. I'm not really sure when, but sometime later down the line. Okay, so I'm just going to kind of read what's written here a little bit, so you can either pause the video and just read this or listen to my lovely words. Okay, so suppose I have an input of 5 into a function, and it returns an output of 8. Right? An inverse function swaps x and y. So you just take your x and y and you switch them. So if my input is 5, that's x, and my output is 8, which is y, then I just switch those, right? So then if I input 8 into the inverse, meaning 8 is now x, then the output of the inverse will be y, which is actually what we originally input. So all of this is just to say that x and y switch. Your inputs and outputs are switched. So here's a few things that we really need to know about inverse functions for now. And that is we denote the inverse of f being a function, as f inverse. And we talked about this in class. The superscript of -1 is not an exponent. We use this notation in a particular context. So if I say x to the power of -1, that's a negative exponent. And I know that because we usually use x as a variable. So x to the -1. And we're actually going to talk about negative exponents in this unit as well, if you don't know what they are. So if you're not sure what a negative exponent is, don't worry, we're going to cover that. But for functions, when I do a little f and then a little exponent of -1, you might say, it's not really an exponent. I wouldn't really write f squared or something like that. This is its own notation used for this context of inverses. Okay? It is important to note that not every function has an inverse. We'll be exploring this in class next time. But just know that you can find an inverse function, kind of, but not every... If you find the inverse, it's not necessarily going to be a function, if that makes sense. A function, if it has an inverse, we call that invertible. So f is invertible if it has an inverse. Now, the basic thing we're going to be doing in this video is to find the inverse function. And the basic process is swapping the x and y values and then solving for y. I will show those couple examples coming up in just a second. We do want to verify that the inverse function we found is a function. And you can verify this using the vertical line test, right? Because if I have a function that does this, well, that does not pass the vertical line test, right? That meets it more than once, so that graph is not a function. So, if I have something like this, which we might see, that's not a function because it fails the vertical line test. And then lastly, the inverse of a point. So if I have the point on the original function x comma y, the inverse of that is y comma x. So very quick examples right here. I mean, extremely quick. The inverse of the point 3 comma negative 11 is negative 11 comma 3. I simply switch them. Some students sometimes confuse inverse with opposite. Opposite is when you change a sign. Notice 3 did not become negative 3, negative 11 did not become positive 11. This is just a little misconception to look out for because sometimes students think inverse means opposite. And that's a little bit different in math because opposite particularly refers to sign, right? It's like plus or minus. Positive is the opposite of negative. You wouldn't really say positive is the inverse of negative unless you're talking about addition as an operation. Okay, example 2, I've got a table of values for the function f shown below, and I'm assuming that f is a function. We don't know what this table is, but we're hoping it is a function. Let's now create a table of values for the function f inverse. And this is just to show you that it doesn't work for just one point, it works for all points. So if I make a little table here, let's say, I don't like that x. There we go. X and f inverse of x. I will simply switch every single one of these table values. 3 comma 10, negative 10, because negative 10 comma 3. And 5 comma negative 15 because negative 15 comma 5. And 7 negative 21 because negative 21, 7. That's it. That is it. You simply swap them. Okay? All right, cool. There we go. Let's proceed. Very, very simple examples. Okay, now this is the real main point of the video. This is what really matters and what I want you to watch, understand, and practice before coming to class next time. I have 2 examples here that I want you to watch. I would take notes on these 2 examples. And on this slide, we have just some practice problems. I highly recommend you practice this before coming to class, okay? All right. So here's my first example, example 3. This actually is a linear function. Linear is the most basic function. It's the most simple function. So I just figured, let me just illustrate the idea of finding an inverse function so you can see what the process is with something very familiar like linear. And then I'll do an example with a square root so you can see that too. Okay? So I've highlighted the steps in gold here. The steps are, step 1, you will change the function notation f of x to y. Then you will swap x and y, and then you will solve for y, and then to formalize it, and this is important because we want to formalize this, is to change y into the inverse function notation f inverse of x. So here's what that looks like. Here is step 1. I will rewrite this equation using y substituting for f of x. You see, all I did was replace this f of x up here with y. Yeah? Now, step 2, I will swap x and y. So x becomes y and y becomes x. I will now solve for y. So I'm going to figure out y in terms of x. So to solve this, I will, let's multiply both sides by 5. Yeah, we'll take this guy, we'll multiply by 5 times 5, and then that gets me 5x equals 3y minus 2. We'll add 2 to the other side, so it's 5x plus 2 equals 3y, meaning, what does y equal? Y equals 5x plus 2 over 3. All I did was divide by 3 right there, right? And ta-da, I have solved for y. So the final step is once you find y, this is the 4th step, change this y into inverse notation because that's the whole point of this. we want to label the inverse function f inverse of x equals 5x plus 2 over 3. And that's our result. We are done. We will box that. That's a terrible box. I will attempt to box that again. Much better. And that's it. You just change the function to y, you swap x and y, you solve for y, and then you just finalize your answer writing it in inverse function notation. That's it. Okay. So let's do example 4. Let's do another one of these. So step 1, I'm going to rewrite this function in as y. So y equals 2 root x plus 3 minus 8. Now swap x and y. That's step 2. So like so. I have switched x and y. And now I just solve for y. So I'm going to just gradually peel off these things. The first thing I'll do is add 8. So I got x plus 8 equals 2 root y plus 3. We'll divide both sides by 2 here. If I do that, I do get 1/2 x plus 4. I decided to divide 8 by 2 because it's 4. And this equals square root y plus 3. Now, I'm trying to get y alone. And we've talked about the inverse operation of squaring is taking a square root, right? You see, if I have x squared and I want to get x alone, I take the square root of x squared. This gives me x. But if I had square root of x, I would raise square root of x to the power of 2 so that it gives me x, right? You see how these operations undo each other, right? Taking a square root is the inverse of squaring, as is vice versa, yeah? So, I'm going to erase this. I will just simply square both sides. I will say this is squared, and this is squared. Now, I'll leave it like that, I guess. I'll say 1/2 x plus 4 squared equals. Now, if I square away that square root, I just get y plus 3, which means, well, subtract 3 to the other side. Y equals 1/2 x plus 4 squared plus 3. That's a quadratic, right? And that's pretty much it. That's our answer. I'm going to say step 4, f inverse of x equals 1/2 x plus 4 squared plus 3. And that is the inverse function. Done. You could expand this, though. So I might put that in yellow. You could expand this, ... by just simply squaring that. You say f inverse of x equals 1/2 x plus 4. And since we're squaring it, we're going to multiply it by itself. Right? And so I'd get a half times a half is 1/4 x squared. Half x times 4 is 2 plus 2, so that's 4x plus 16 plus 3. So that's 1/4 x squared plus 4x plus 19. Okay? So, yeah. I don't really care about that. I mean, that's not really my focus right now. My focus is just showing the inverse, right? Finding the inverse function. Now, we can try and verify that these are indeed functions by using the vertical line test, but I'll tell you that they pass it, all right? They do pass it. Because this first one's just a linear, and linear always passes the vertical line test. And this one's quadratic. That passes it too. Really, the only time it's not going to, in the context of this unit, is when you find the inverse of a quadratic and get a square root function. That won't pass the vertical line test. But that's more for class discussion, less so the topic of this video. Okay. That is essentially it. That's all I really want you to know for now. There is a part 2 to this video, so make sure to watch the next video that comes after this. I did split these into 2 parts just to separate the concepts, but you do need to watch them both. The last thing is this slide here. This is a recommended independent practice. There's one here, and then there's another for the part 2 video. This just asks you to find the inverse of each function, and then see if you can figure out whether that inverse you found is a function, and maybe try things about, figuring that out. Don't really Google this unless you really just are very curious about inverses and want to expand your learning and get a glimpse into what we're going to learn later, because online you're probably going to see something about composition of functions, which we haven't talked about yet, but we will. So if you don't want to spoil the fun for yourself, just try this on your own. Don't rely on the internet, and we'll go over it in class. Okay? So, yeah. I'm sorry, I'm coughing. So you can pause this video, but I also upload these lesson notes to Schoology, so go check them out up there. And I'm so sorry, I'm ruining the end of the video with my coughing. Here are the answers, because I don't really care. This is for you, right? This is your practice. So you can take a look at these answers to verify that your work is good and clear, and there you go. All right, that's it for this video. Again, really do practice this. I know you might be tempted, oh, I'll get it in class. Guys, practice this, all right? Even if you don't do all 4, practice 1 or 2 of them, okay? Just take 5 minutes, 10 minutes out of your day. You give this a go. Okay, hopefully you enjoyed watching the video. Again, sorry for coughing and all over the place, but there you go. All right.